so today is the first day of Unit 9. Unit 9. Oh, sorry. That's okay. And let me get that printed. Okay, so Unit 9, which is on exponents. You guys may have seen this before in previous classes. You might have dealt with this in the previous class, so hopefully today's actually isn't.
Microsoft link is unavailable because the version of Microsoft Office is not.
Thank you, Chair.
Use smartly.
Okay, so as you'll see on your assignment sheet, we are looking at the test being March 14th, which is perfect because that's Pi Day. So what a wonderful day.
Pi Day.
This is a pretty short unit. There's only 4 days of instruction. All right, so taking a look at our warm-up here. This is something that we did back in Unit 1. Was it the first unit, I think? Maybe the second unit? Where we filled out this chart dealing with our exponents. So if I have x cubed, what is that expanded? X times x times x. Good. X times itself 3 times. That exponent tells me how many times I'm multiplying by itself. Now, since we don't have an actual value here for x, our answer is just x cubed. There's no numerical value. We don't have a number for it. All right, so then here I have 3 times 3 times 3 times 3 times 3 times 3. What would that be in our first column?
3, 6.
Let's use proper math verbiage. Good. Thank you, Joe. 3 to the 6th power. All right, 3 to the 6th power. We have 6 3's multiplied together. And what is that numerically? What's your answer? 729? Is that what you guys said? Good. All right, so then our next one, they give us 10 to the 4th. How would that be expanded? Good. 10 times 10 times 10 times 10. And our answer is?
10,000.
Whoops, I put my comma in the wrong place. 10,000. You'll notice there are 4 zeros and an exponent of 4. That is characteristic of all your 10 to the power. All right, next column. They give us 12 times 12. Let's skip to our last column.
144.
Good, 144. Who knew that without the calculator? Nice. All right, and what is that going to be in my first column? Good, 12 squared. Okay, 4 to the 5th, we have 4 times 4 times 4 times 4 times 4. Okay. 1,024.
4.
Did we get that? 1,024. Good. All right, and our last one. It looks like this is a doozy. What's our last one? What's the first column? 8 to the 7th. I cannot do this one in my head. What would this be as my answer? Give me the numbers slowly.
2,097,000.
No, it's 209.
209.
7152. I think.
Oh.
Is it that?
7152.
Million. That's what I said. 2 million. You don't know how to say numbers.
7152. 209 7152. We agree?
Yeah, that's it.
All right, so let's read that mathematically.
200,000. I know.
So it'd be 2,097,152.
See, I was right.
You were on track.
You said 2,000,009.
I said
He said 2,097,000. He was right. I just didn't catch the zero. Good. All right. Any questions on our warm up here?
Shut up, you called out too.
Q1 was correct and who's reading it off, right? Q1. Okay. So let's take a look at our notes for today. I'm gonna go ahead and so this is worksheet 1. Get that out. All right, who has seen this type of stuff before?
What is that?
Good. Worksheet 1. Worksheet 1. Did you not get worksheet 1? Is there one that did not get worksheet 1? Just okay. Maybe probably. All right. So here we have 3 to the 4th, or 3 to the 4th power. What is, anybody know what the term is for my bottom number, the large number here? Base. Very good. And of course, we are all about that base.
Yours was bad.
I thought it was
Said
good.
it.
All right, and then my 4 here, what is that? What's the term for that? Exponent. Very good. And what is another term for it? Power. Who was that, Muhammad? No? Muhammad? Nice. Exponent or power. Right, that's why we say 3 to the power of 4, 3 to the 4th power. Alright, so what does this mean? What does 3 to the 4th mean for us? Yeah. 3 times itself 4 times. And what is that actual numerical value? 81. Good.
81.
3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Very good. Okay, so this is just bare basics. We have powers, exponents we're dealing with. Now, what we're going to talk about today in the next couple of classes is what our rules are when we're dealing with powers, when we're dealing with exponents. Our first rule we have here is called the product of powers rule. So when we have two terms here that are being multiplied, each with an exponent, and it is the same base, remember this is the same thing as, so x cubed is x times x times x, x squared is x times x. Well, what is this altogether? What is that the same thing as? X to what power? To the 5th power, right? We have 1, 2, 3, 4, 5 of these. Alright, so how did 3 and 2 become 5? What operation did we do? We added them together, right? So what do we do to our exponents? We added them together. And that's our first property. To multiply powers with the same base, and that is extremely important. It has to be the exact same base in order to do this. Then we add the exponents. So again, they have to be the exact same base, and then you just add your exponents together to simplify it. So for example here, a to the m times a to the n is going to just be a to the n plus n. So you just add your exponents together. And again, your bases must be the same. So this is when we are multiplying powers with like bases, with the same base. So when we're multiplying powers with the same base. Okay. So I'm just going to pull up a bunch of these. This is not on your sheet in front of you, just to give us some very simple basic practice with this first topic. Oh, that's kind of hard to see, isn't it? I didn't realize it'd be so small. Oh, no, leave those lights on. Nice try, though. Can you guys see that all right?
Yes.
Okay. X squared times x cubed. What would that give me? X to the 5th. So I want everyone to be thinking and joining in. All right, x to the 5th. What about our next one? X to the 9th times x to the 10th. X to the 19th. Good. All right, our next one. Y squared times y to the 4th. Y to the 6th. You guys are good. Z times z to the 8th. Z to the 9th. Z to the 9th. Remember that this is just an exponent of 1, right? If I were to write this all out, I would have 9z, so it'd be z to the 9th. Good. All right, moving on. Z to the 14th, z to the 100th. Z to the 114th. Good. Ooh. B to the 7th, B to the negative 3rd.
B to the 8th.
Joe, what'd you say? B to the 4th. Remember, we add these together. 7 plus negative 3 is 4. So this would be B to the 4th. Good.
God is nice.
All right, let's do another one like that. B to the 7th, B to the negative 3rd. That is the same thing, isn't it? That sounded familiar. Okay, G to the negative 2nd, G to the 5th.
3.
Good. G to the 3rd. No, that's not what I want to do. Alright. k to the third, k to the negative 9.
Negative 6.
K to the negative 6. Good.
Hold up.
K to the negative 6. Positive 3, negative 9. Since they're opposite signs, think of 9 minus 3, which is 6. But my 9 is the larger number, which is negative, so the overall number must be negative. N to the negative 7th, m squared.
Negative 5.
Good. M to the negative 5. All right, m to the negative 10th times n to the negative 4. Negative 10 and negative 4. That is, they're both negative.
Positive.
If I have negative and negative, it doesn't suddenly become positive when we're adding.
Negative 14.
Good, negative 14. I'm sorry, I did not hear you say negative 14. Okay, and then my last one down here, n to the 12th, j to the 10th. Ooh,
Oh, no.
tricky.
Oh, it's. Shut up, bro.
Can we do anything with this?
No.
No, why not?
I don't think so.
They're different bases, so we cannot combine it together. There's nothing more we can do. They are different bases.
Hey.
Thank you so much for this new jacket. All right. So we can't do anything more with these. It has to stay as m to the 12th,
Okay.
j to the 10th.
Huh?
Right, questions on that?
Weird.
This is pretty nice. Okay, so let's take a look at our next rule. Good job with that, guys.
Still laughing.
Okay, so we have x
What if
cubed
she had the big coat on?
squared.
Oh, yeah.
You're not even on the right page. Thank you. Okay, x cubed squared. So what does it mean if we're squaring it? Multiply by itself, right? So this is the same thing as x cubed times x cubed, right? Because it's this times itself.
Why'd you put a 3 over the section?
Oh, cube.
Okay, I'm here.
So yeah, so this is this inside term. Squared means it's multiplied by itself. And so what would that give me? X to the 6. Okay, so let's try to figure out what our rule is. What happens with our exponents here? How do we get 6? Multiplication. Good. What do we do with our exponents? We multiply them.
So it's just 3 times 2.
So x to the third raised to the second power. Multiply your 3 times 2 is 6. So this is when we have a power to a power, an exponent to an exponent. So to find a power of a power, we multiply the exponents. So a to the m, the whole thing raised to the nth power, we just multiply our exponents, m times n. Again, we're going to be dealing with actual numbers. Questions on that? Okay, so let's take a look at some just simple practice problems of this. Kind of help you get the hang of it. Okay, don't look. Hold on.
What?
Oh no.
What is it? I swear to God, people in the room.
But it's my girls.
Okay. So taking a look at our first one, x squared to the third. What is that going to give me? X squared to the third?
6.
X to the 6, good, that's the one we just did.
Did not hear all this talking.
X to the 9th raised to the 10th? 90, good,
I did that without
good.
Yeah, anybody. Just 9 times 10.
Be encouraging, guys.
Nice effort out there.
Okay. How about
8.
Is it broke?
8. She knows I like it now.
okay, y squared to the 4th?
Why? 8.
Y to the 8th?
I did that without my calculator.
Z to the 4th to the 8th.
6.
Z to the 4th raised to the 8th.
24.
Woo!
No.
33.
32, good, that's one of my favorites. Z to the 32nd. How about z to the 8th raised to the 7th?
56.
Nice.
Hey, that's my
56.
favorite
Good.
one.
Z to the 56.
Wait, guys. What?
Math class is fun.
All right. How about b to the 7th raised to the negative 3rd?
You don't know that anymore. Say no.
B to the negative 21st. Good job, Joe. I know
Negative
you said
21.
it. I want to hear others. Negative 21st.
Negative 20.
21st.
B to the negative 21st power.
Oh, man.
7 times negative 3 is negative 21.
Yeah. Did we have to say the whole thing?
Can you fix the
Just say
colors?
21 instead of
They're all messed up.
Yeah.
I like it
Huh?
that way. G to the negative 2nd raised to the 5th.
negative 10.
So we say G,
G to the negative 10.
10.
That's it.
All right, next K to the 9th raised to the K to the 3rd raised to the negative 9th.
Oh, my fingers out.
Negative
27.
Good job with the trick.
Negative.
You guys, come on, we talked about that trick. Whenever you have powers of 9, yeah, but it's still great. It works for your entire life.
I don't think it
3 times 9, go to the 3rd finger, 27.
What? I didn't see that.
So whenever you're doing powers of 9, use your fingers to help you out. So we're doing 9 times 3, so you put down your 3rd finger, so 27. 2, 7.
Oh my gosh, that's it.
All right, how about n to the negative 7 raised to the 2nd?
Negative 14.
Negative m to the negative 14 power. Good. M to the negative 10th raised to the negative 4.
40.
M to the positive 40th power. Good. Negative times negative becomes a positive. M to the 40th power.
Nothing.
Oh, last of that one. Okay, so let's go to our next one.
Nothing to the 0 power. Or is it?
Daddy.
It's 0. That's what it is.
All right, questions on our rules so far? Q1.
I'm good.
All right, so our last one, power of a product. So what we have here now is that our inside, we have 2 different bases that are being multiplied together. And the whole thing is raised to the 3rd power. What do we do, Jeff? Yeah, we actually distribute this power to both pieces here.
What?
So we have x cubed, y cubed. Because essentially what this is, let's take a look at what this is. So x times y raised to the 3rd power is xy times xy times xy, right? It's multiplied by itself 3 times.
Oh.
Well, what's x times x give us?
X
X cubed.
Cube.
And what's y times y give us?
Y cubed.
Y cubed. So we have x cubed, y cubed. That's where that comes from.
that's
So-
the answer.
What?
That's the answer.
Yeah. So as Joe said, what did we do to each? We distributed the exponent. What do we do to the exponent? We distributed to each term. Really? No? Okay, now it is extremely important you understand this next part I'm about to tell you. Notice that what we have inside of my parentheses is a product. What operation does that mean? Addition, subtraction, multiplication, or division? Multiplication. What's inside our parentheses is multiplication, okay? So if I have x plus y to the 3rd, this is not equal to x cubed plus y cubed, okay? That is
What is
incorrect.
it then?
It's something you're going to learn about later where we have to do x plus y times x plus y times x plus y, and you actually FOIL. So you have x squared plus xy, which is 2xy, plus y squared, and then you would multiply it by that last. So that comes later.
How
That
far
comes
later?
later.
How far later?
End of the year.
Okay.
Okay. So I just want you to make sure you understand right now that if we have addition in here, the only thing you know right now is to write that out as x plus y times x plus y times x plus y.
That's all.
That's all you know right now, okay? I do not want you to
Like in
distribute
Spanish.
this here. We do not distribute it when we have addition, subtraction in there. This is only for the power of a product, meaning what's inside is being multiplied.
Huh?
Anybody not understand what I'm saying there? Because that's an extremely important point. Okay. All right, so to find the power of a product, we distribute the exponent to everything. So a, b, the whole thing raised to the nth power, it's going to be a to the n, m
That's a lot of
times
words.
b to the n.
That might not be right.
It's a letter
Mm.
word.
Alright, so again, we distribute that to everything inside the parentheses. Now let me ask you this. If I had a C outside of here, would I distribute my M to that C?
Yeah.
If I have my C outside of my parentheses, would I distribute that? No. C is not included. Notice the parentheses tells you what that exponent is being applied to. My C is not included in the parentheses, so it does not get the M applied to. Okay? So it's only for what's inside my parentheses when we're multiplying. Questions on that? Okay. So again, let's do some simple problems with this. And let me zoom in.
X cubed
That's the same
times y.
Shut up. I was faking. I wasn't serious.
Don't say nothing.
Alright, so here we
Don't
have
say-
x times y raised to the third power. What is that going to be?
X cubed.
It's not
Y
nice.
cubed.
Good. X cubed, y cubed. Gentlemen. We distribute to both pieces. Alright, next. J times k raised to the 8th.
J raised to the 8th.
J to the 8th, and what else?
K to the 8th.
Good, k to the 8th.
This is so easy.
Alright, next up. WZ, quantity raised to the negative third.
W to the negative 3.
Negative 30.
Good, y to the negative third,
Yeah. Z
And?
to the negative 3.
and z to the negative third. Are we feeling good so far?
Great.
C.
Great.
Like Tony the Tiger.
Okay. A times B, entire thing raised to the 100.
And B
Good.
That's a fuss.
A to the 100,
Say B. I mean D.
B to the 100. Okay.
That's it.
Nope.
Oh.
A squared B
A
cubed,
to 6.
entire thing raised to the third.
And then B to the 9.
Good. A to the 6
How'd you do that?
times B to the 9. A to the 6 times B to the 9. So notice we distribute to both pieces. So what we have happening here,
Oh. It wasn't me. I'm still trying.
okay, so what we have happening here is it's A squared raised to the third, right? We have to distribute the 3 to both of them. And then B cubed raised to the third. And then as Joe did, we have to multiply those, right?
And
So that gives
trade it,
me
no.
A, and trade it, yes. A to the 6,
Yeah.
B to the 9. Now you don't need to write that in between step there. You can go ahead and distribute and recognize you're going to multiply those. And I distribute my 3 to the 2. I multiply that and get A to the 6. But I distribute 3 to 3, multiply it together gives you B to the 9. Okay, so A to the 6, B to the 9, that would be your final answer. Questions on that? Okay, let's take a look at another one. Making them a little bit trickier for you. A to the negative first,
A negative 4 times
B to the second, all raised to the 4th power. Again, we're going to distribute my 4. So we have A to the
negative 4.
negative 4, B to the 8. 2 times 4 is 8.
Not that.
Questions on that?
No.
Alright, I want to see everyone's thumbs up, thumbs middle, thumbs down, how we feel with what we've done so far, especially those last couple ones.
Do something.
Okay? Let's do a couple trickier ones.
No.
What?
What the?
H to the negative second, J to the third, whole thing raised to the negative
You
fifth.
get an H to the
Oh, I
10
thought the J
power,
was like times 3 for a second.
and then J to the negative
I thought he
15.
said.
Good. H to the 10th power, and J to the what?
15.
Negative 15. Good. Again, we distribute to both. And since it's a power raised to a power, we multiply them. Negative 2 times negative 5 is positive 10. 3 times negative 5 is negative 14. Okay. Next one. X to the negative third, y to the negative fourth, all raised to the negative 8.
X.
X to the what? Good. X to the 24th.
Y to the 30.
And y to the close.
I can't see the other two.
32nd. Good.
To the
Again,
32nd.
we distribute
Yeah, I already said
and multiply power to the power.
Come on, man, I was so close.
Questions on that one?
No.
Tasha.
Oh yeah, I already wrote it down.
We're not writing these down. Nice try, though. Alright, and then I think this might be our last one. Oh, nope, there's one more after this.
X5, Y5,
X, Y, Z, all raised to the fifth power. What was it, Q1?
X to the 5th.
Seniors at
To the
Herman
power.
High School will flag their obligations.
And Z to the
Next year.
Good. We distribute, even though there's 3 of these, we still distribute to every single one. Alright. And now I think this is our last one. Alright, how about this last one? This one's pretty difficult.
Ripped up.
Good, Morgan. X to the negative 14.
I can't see that.
What about my Y?
Why?
You don't say this to anybody, don't say this.
Negative
That's why I know.
7.
Negative 70.
Negative 70, what?
Alright, Y to negative 7, then what about my Z?
To 70.
Oh.
Z to the positive 70.
I didn't see his Y.
Power. Alright, so make sure you don't lose your Y's there. Just stick with me.
Wait.
I don't like this.
Oh, never mind.
We have an exponent of 1, so we still have to distribute my negative 7 to my left.
Oh,
So I have x to negative 14, y to negative 7, z to the 70. Alright, questions on that? Okay, so let's take a look. Alright, I want to make one more note on our notes page before we do some practice problems together. A very important concept with exponents. So, let's just write it off to the side here.
Which one's fight? I'm making fight. You can throw hands.
Alright, a couple of really important properties is if I have 0 to, let's say, the 1,283rd power, what is that going to be?
0.
0, because 0 times itself how many times, doesn't matter how many times, it's still going to be 0.
Actually,
Right? Another one, if I have 128 raised to the first power, what does that give me? 128. So anything raised to the first power is just the number itself. Now this last one is kind of the really weird one. If I have any number, so I'm just going to use x, raised to the 0th power. Everybody know what that is?
it's like 0.
X raised to the 0th power. Try this in your calculator. In your calculator, put 5 to the 0th power.
I got this.
In your calculator, try 5 to the 0th power.
1.
Alright. Try got 1. Anybody else get 1? Mohammed Spring. Okay, now I want you to try 200 to the 0th power.
It's gonna be 1.
Say it again.
200 to the 0th power. 200 raised to the 0th power.
Weird.
You guys get 1?
You're dirty. That's what Derek said.
Alright, so no matter what our base is, as long as I have an exponent of 0, your answer is always 1. Okay? So exponent of 0 gives you an answer. Questions on that? Okay. Also, I just want to recap with everyone calculator stuff. Where do we find, say I wanted to do to the power of 1,000
You do that little up button under
the little up button, where is it?
under the clear.
Good. This button under my clear lets me put in the exponent. So, for example, 0 to the 1,283rd, I do my little caret, and then 1,283rd.
I don't like
Now,
carrots.
a lot of you, your calculators will look like this, where it would say 0, caret, 1,283. Some calculators will have it actually go up into the exponent. Same thing either way.
The important thing to remember when it goes, guys,
What?
the important thing to remember when it goes up into the exponent is if you are entering more than that into your calculator, you must hit the arrow right button and the exponent.
Yes. Likewise, so because we'll have problems that are a bit more complicated, where you're not just going to have a single number raised to an exponent. So say there's more going on, you need to put this in parentheses and it gets done with your expression. But as Mr. Rabbit said, if you have one of these updated ones, you need to actually hit the right arrow button, so 0 to the, let's say, 28th power, to get out of my exponent to arrow over to get out here. Otherwise, you're going to keep typing in the exponent.
Right there.
Thank you, Trey. Okay, questions on this? Okay, let's take a look at the back side. Alright, our first problem. It says to simplify, make sure you do read the instructions. Sometimes we'll have you evaluate. 3 to the 4th times 3 to the 6th. What is this going to give me? 3 to what?
10.
3 to the 10th. We add our exponents together. When we're multiplying like bases, we add the exponents. And I do want you to actually punch this into your calculator, see what you get. And I want everyone punching this into their calculator, see what you get.
59,400. I mean, 49.
59049.
Yeah, 59049.
Good. So we are looking for both pieces here. I want to see your 3 to the 10th, and I want to see the entire actual numeric value.
It's just a simple
But I need to see both. I want to see it simplified with your exponent and then the actual evaluated piece. All right. 2 cubed raised to the 2nd power. What would that give me? 2 to the 6th. Okay. And punch that into your calculator. 64. Very good. All right, now we finally get some variables going on. All right, Tayshawn, I'm going to count on you for this one.
Here, Tayshawn.
All right, number 3. What do I need to do? I have a product raised to an exponent. What do I do with my exponent?
Say no. I don't know. What you want to do?
Distribute.
Oh yeah, because it's in the.
We have the products inside my parentheses. So I'm going to distribute this to both my -5 as well as the a. So notice it's the entire -5 as well as the a. You need to include that negative in with your 5. Alright? And what's -5 cubed give us?
Negative.
Not quite.
Negative
Good. -125, a cubed. Good. A negative to any odd power actually gives you a negative result. Alright, questions on 1, 2, or 3? Okay. So let's move on to a little bit more difficult ones. Number 4, x times
7x.
x to the 6th. Is it 7x?
No,
X
X
to
is
the
7
7th.
power.
X to the 7th, right. 7x is not the same thing as x to the 7th, so make sure you're careful with that. We add our exponents together. This is an exponent of 1. This is x to the 7th. Can we simplify this anymore?
No.
No, we don't have any actual numeric value. Number. Alright, how about 3 times 7 to the 2nd power? What do we have to do with that power of 2? Very good. Distribute. So I have 3 squared times 7 squared. And what is 3 squared? 7 squared. And 9 times 49.
I'm pretty good at this.
441.
You just do 3 times 7 and then just do that.
Trey just asked a wonderful question. We could,
Yes, it gives the same one.
yeah, we could simplify the inside first. 3 times 7 is 21. And then 21 squared, 441. 441. Sorry, 441. Very good. All right, number 6. Okay, so we've got some different things going on here. Make sure you don't forget back to your order of operations, PEMDAS or GEMDAS. Instead of, so PEMDAS is parentheses, G is same thing as grouping, so parentheses. Okay, so do we have parentheses here? Do we have grouping? Yeah, we have our parentheses right here. Now, can I simplify, when I'm doing my parentheses, I'm looking to simplify the inside. Can I simplify 2 times y? No, there's nothing more I can do with it. So I'm done with, there's nothing more I can do inside my parentheses. Alright, what does the E stand for? Exponent. So I need to take care of my exponent next. Alright? Can I simplify my exponent here with y squared?
No.
No. So we still just have 3y squared. Can I do something with my exponent of 3 though?
Yes.
What do I have to do?
3 times 2 and then y. I mean,
We have to distribute to both.
2 to the third.
Good. So we have times 2 to the 3rd power. And distribute to your y. So we have y to the 3rd power. Okay. So that took care of our exponents. Now look, all we're doing is multiplying here. So let's simplify it first. What is 2 cubed? 2 cubed is 8. Good. So this same thing as times 8y cubed. Like a snowman. Okay. So now we're just multiplying. So what can we multiply together?
Y.
We can multiply our y together, and what else? 3 and 8, right? What's 3 times 8? 24. And what's y squared times y cubed? Close. When we're multiplying, what do we do with our exponents? Add our exponents? 5. Right. So when we're multiplying, we add the exponents. Add the exponents. Alright, so again, when we're multiplying like bases, we add my exponents together. So we have 24y to the 5th. Questions on that? Okay. Now our next instructions are a little bit different. First, it says simplify, then evaluate when a equals 1 and b equals 2. So we're going to simplify it down to a nice expression such as what we just did here. This guy. And then you take your values and put it in. So let's start with number 7. Kind of more simple one. A squared times a to the 3rd. A to the left. To the 5th. Good, we add them together. Okay, so we simplify. Now evaluate when a equals 1. What do I do with that 1? Put it in where? Put it in for a. Now when I'm doing with exponents, you want to make sure you use your parentheses.
That's
That's
exactly
1.
Them up.
And what's 1 to the 5th?
That would be racist.
1. Yeah, 1 to any power is just 1. Okay, so we have 1. So again, I'm looking for the simplified expression and then the actual evaluating of it. Alright, so number 8. We've got a lot going on. So again, let's think of our GEMDOS here. Our order of operations. Whenever we're simplifying, we need to follow this order of operations. So we have parentheses, grouping. Yes. Can I simplify, though, a times b to the 3rd? No, they're not like terms. There's nothing more I can do there. So I have an exponent. Yes.
Yes.
I've got to distribute this guy. So this is negative stays outside. That's not being distributed to. That's sitting in front. All right, when I distribute my 2, what do I get? Good. A squared, Alex, and what's the b?
B squared.
E6.
B to the 6.
I got you, man.
E to the 6. Because we multiply my exponents that are raised to the power. Power raised to the power. 2 times 3 is 6. Okay, so we took care of our exponents there. Now, again, can I simplify inside my parentheses at all?
No.
No. What is this negative? What number can I put in here?
-1.
Right, so this is just negative 1 times a squared times b to the 6th. Notice everything I'm doing here is multiplying. So that's my next step, multiplying. Alright, well, can I simplify? Multiply it all? Is there really things that I can multiply together? I mean, we have this negative here, right? This is all just multiplication. So it's just negative 1 times a squared times b to the 6th. There's nothing really more we can do. Now, you don't need to have that 1 there. You can just leave it as negative a squared b to the 6th. You can write in the 1. It's not necessary, though. Why did I not distribute my negative 1 to both pieces? think back to when we dealt with distributing. What's the difference between that and this? What's the difference here?
Oh, because the thing at the top, we don't do.
Not necessarily with the exponents, but yeah. When we were first dealing with distributive property, that's only when we are adding inside of a parenthesis. Because what we're saying is both the a has to be multiplied by -1 and the b needs to be multiplied by -1. But here this is just straight multiplication. We can think this as 3 individual things. -1 times a times b, which is just -1 times ab, or just -ab. So again, when we are dealing with regular distributive property where we have that number multiplied in front, we only distribute when we're adding or subtracting inside. Our exponents, though, are kind of the opposite of that. Our exponents we distribute only when we are multiplying inside. So make sure you don't get those two hooked up. Okay, so we have -a squared b to the 6th. Alright, so we've got our simplified answer here. Now we need to evaluate when a is 1 and b is 2. So I have negative a is 1, so 1 squared, and b is 2, so 2 to the 6th. Notice again, be careful with your use of parentheses. My negative is not being squared. It's not included with your a, so it's not being squared. It's sitting by itself out in front.
It's not.
It's not. It is not with my a. If it was being squared, it would be like that. But it's not included in the squared, so we don't square that. Alright, so what is 1 squared? Good. And what is 2 to the 6th? 62. So what would -1 times 62 give me? -62. Was 2 to the 6 really 62? 2 to the 6?
64.
Woo, 64. Okay. 2 to the 6 is 64. That makes me feel a lot better. Alright, so again, only my a is being squared, so only the 1 is being squared. Only my b is being raised to 6, so only 2 is raised to 6. We have negative times 1 times 64 is -6. Questions on that one? Questions, sir?
Wouldn't it just be the same if we did square it with the negative?
No, because a negative squared would be a negative times a negative, which gives you a
But it
positive.
eventually becomes negative.
You said that for
But-
exponent.
Trey, if you had -1 squared, -1 squared is -1 times -1, which gives
The
you
one on top of it.
positive 1. So it would end up giving you a positive.
So we just make it a negative at the end.
Yeah. So you can think of this as -1 times that, if that helps you out. And -1 times +1 is -1. And then -1 times 16. Or you can just carry your negative. Alright, our last one before we give you time to finish up your midterm there. Alright, number 9. We've got a lot going on. Alright, first things first. Gem dust.
On the real graph.
Say, Sean,
Yes, ma'am.
my dear.
What?
G. Grouping. Do we have any grouping in number 9?
Yes,
What do we have?
You have. You got
We have a couple sets of parentheses,
You
right?
have a lot.
Let's take a look at our first set of parentheses. Can I simplify the inside there? What does that become?
Oh,
B to the 5th. Good, Alma.
Numbers.
B to the 5th. Trey, why is that B to the 5th?
Because
2 times we added them together.
Yeah, we add our exponents together. Okay, so we took care of one set of our parentheses. Say, Sean, can I simplify B squared?
Yes, ma'am.
I can't?
No, you can't.
I can't?
No, you can't.
Why not?
I think you can.
Oh,
Actually.
you think I can?
Yeah.
Okay, so B squared by itself. Can I do anything more with that?
No.
We don't have anything for B. There's nothing else to combine it with. So I cannot simplify my inside my parentheses, so that just stays.
I don't think so.
Okay, so we've taken care of our grouping. Q1, you're next.
You said 3.
Exponents.
Yeah.
Alright, can I do anything more with B to the 5th? No. Can I do anything more with b squared raised to the 4th?
Yeah.
Yeah, what does that become?
B. What's it called? No. Yeah. Right.
Yeah, b to the 8.
These guys
Good.
hate the most.
No. What's it called?
So we took care of exponents. Multiply. Are we multiplying here? Yes, b to the 5th times b to the 8th. Can we simplify that? What does that become? Good, b to the 13th. There's nothing left to do. Alright, so there's our simplified expression.
You gotta plug in B.
And now we have to evaluate it. Good. You alright there, you all?
No.
8,109.
Is it really that much?
Can you just do that?
Yeah. You
Two.
keep going. I thought
See,
you.
that's what I'm saying.
think
You
it
did-
is.
Wait, where'd you
you
get the
did
2
weird.
from? Yeah.
He just
He did something. That's good.
You did what?
he did something. So I thought he
Did you do it from the very beginning?
Yeah.
8,109.
So you can substitute in 2 to get your answer in the end, but the fact that it says simplify first means you do need to follow your properties of exponents to do this first. And then substitute in. Alright, Joe, can you read out for me the number you got?
8,192.
Thank you, Trey, but Joe, can you read it out for me slowly?
8,192.
Is that what we all got?
Wait, where'd you put 2 from?
So it says evaluate when b equals 2.
Oh, okay.
So I'm just following the instructions.
I thought he was.
Oh, that's a good question. Make sure you do follow the instructions. Sometimes there are additional things to do.
Yeah. he's
All right,
never back into
questions
math
on
class.
We ought to see.
Okay, so
For that.
what I'm gonna have you do now, I'm gonna pass out. Did you pass out?
No.
Yes.
Not homework.
That's okay.
It's homework.
If you have work, or you should have worksheet 2 in front of you, so get this out.
Oh.
Worksheet 2. And worksheet 2 is our classwork. So what I'm gonna have you do, no way.
No,
Thank you.
I'm trying to get it right.
Okay, so I'm gonna pass out all the midterms, and then if you're done with your midterm, I'll have you turn it back in. Once you're done, you're gonna work on the classwork.
Wait, what?
Wait, can I read your mind?
Yeah, we can.
No, I'm passing everyone's back out. So I'm passing everyone's back out to you, so you can look back over it with fresh eyes, even if you were done. Take a look through it, see if you need to fix anything, maybe my mistake somewhere. Then you'll turn it in. Yes, please do look back over it. Then you'll turn it back in and work on your classwork.
That was a copy.
And reminder, you do have a mini quiz next class over what we learned today.